This is a question asked by one of my students. So here, this question, it has a light trick, and if you do not follow that trick, it will become difficult for you to solve this question. So first, y is equal to e to the power of a cos inverse x. So here you dy by dx, taking the help of the chain rule, this will be e a cos inverse x into minus a by root over 1 minus x square. So this is minus e uh, a cos inverse x by root over 1 minus x square. Now you bring this here, this side, so this will be 1 minus x square dy by dx, that is equal to minus a cos inverse x. Now here this will be product rule, so when you differentiate it, it will come out root over 1 minus x square dy by dx, plus here this will be root 1 minus x square d2y by dx square, and here this will be equal to, if you differentiate it, you are going to get a square and a square e to the power of a cos inverse x by root over 1 minus x square. You are going to get, if you differentiate it, that means you have to apply the chain rule, and when you apply the chain rule, you are going to get this result. Now you multiply both sides by root 1 minus x square. You multiply both sides by root 1 minus x square. You are going to get 2x dy by dx 1 minus x square d2y by dx square, and this will be a square e to the power of a cos inverse x. So now this is 1 minus x square d2y by dx square minus 2x dy by dx, and this will be equal to a square y. This will be equal to a square y. So 1 minus x square 1 minus x square d2y by dx square minus 2x dy by dx minus a square y is equal to 0. So here this is the slide technique. That means if you have to bring this to this side, but if you go you find out the second derivative again by applying quotient rule, then you will find difficult to solve this problem. So this is how we solve it. And another small questions, it was asked by my student, that we have to give an example of a function, give an example of a function, that is we have to give an example of a function, example of a function which is uh, continuous, example of a function which is continuous, but it is not differentiable, it is not differentiable at 2 points. It is not differentiable at 2 points. So remember that modulus x, this is a continuous function, but it is not differentiable at x is equal to 0. And if you add with this x minus 1, so this is a modulus function, and it is also not differentiable at x is equal to 1. So this is the example, means you remember that the graph of the modulus function is this, your graph of the modulus function is this. So here you see that the slope is here, this is theta, this is the slope of this line, but for this the slope is this, let this be theta 1 and let this be theta 2. So the slope of this graph is theta 2, and here your acute angle, so in the first quadrant your tan theta is positive, but this is in second quadrant, your tan theta is negative. So it is continuous at x is equal to 0. It is continuous at 0, but it is not differentiable at x is equal to 0. It is not differentiable. Remember, it is not differentiable at x is equal to 0. And for this function, x is equal to 1. You have to find an example. So this is your example. This is your example. Thank you.